Hi, 8th graders. Welcome back to science. Today is Monday, January 4th. Happy New Year. And this is the information for January 4 and 5. So today we will do some winter break sharing in class, or we did. We will preview the week and we'll look at minerals. This week, it's all about minerals. So today we'll talk about minerals. Tomorrow is more about minerals. Wednesday, we'll do a virtual identification gizmo. Thursday is a lab. We would normally do that hands-on. We'll do it virtually with some videos. And then Friday, I'll take a little mineral quiz. There's the cover to our new digital notebook. Our plan for the next 3 weeks. Contact information. Study guide, Quizlet decks, the YouTube playlist, the January calendar, and then remember you have a textbook. So pause this video right now and go to YouTube and watch the mineral identification brain pop. Then come back and see if you can identify the different mineral properties and the tools used for each. So please pause this video, go to YouTube and watch that brain pop. Welcome back. Hopefully you found that this streak plate is used for streak, or the color of a mineral's powder. This is used for hardness. A flashlight would be used for luster, and then a hammer would be used for fracture. Here we're going to define a whole bunch of terms. You're going to probably need to pause this video again and make sure you're completing all of these in your notebook. So first, a mineral has 5 things. Something needs to have all 5 characteristics to be a mineral. It needs to be naturally occurring, so you can find it out in the world. Inorganic means it was not and never was alive. It has to be a solid. It needs to have a definite chemical composition, so it's the same chemical formula and makeup every time. And it's a crystal structure, so it's made out of crystals. So if we find these substances and we think they're minerals, we want to try and identify them. And some of the properties are listed below that we're going to use to do this, and they're physical properties. So ones we can observe without changing the substance itself. One is the color of a mineral's powder. Again, that streak. We would use these plates to rub the mineral on and then look at the powder that's left behind. We can look at hardness or its resistance to scratching. We would try scratching it with different materials or using it to scratch different materials, and then compare it using Mohs hardness scale. Density, hopefully you're remembering the formula by now, is mass divided by volume. Specific gravity is the ratio of its mass to the mass of an equal volume of water. We can look at how a mineral reflects light. We call that luster. And then we can see how a mineral splits apart. Does it split apart kind of irregularly? If so, we call that fracture. Does it split with flat planes? We call that cleavage. Again, if you need to pause this video at this point, please do so and define all of these important terms about minerals. Here again, you'll need to pause again and find 10 pictures of the 10 representatives that make up Mohs hardness scale. So again, please pause the video, and your completed project or completed diagram might look like this. We've got talc, gypsum, calcite, fluorite, apatite, orthoclase, quartz, topaz, different varieties of corundum, and then a diamond. Next, let's learn a little bit about these Mohs hardness scale. So here, oops, I don't know why it's doing that. Friedrich Mohs is pictured here. He's a German mineralogist who invented a scale that assesses a mineral's resistance to being scratched. This scale is called the Mohs scale of mineral hardness. Friedrich's scale is based on 10 well-known minerals and assigns a number from 1 to 10. The easiest mineral to scratch is talc, and it is rated a 1. The hardest mineral to scratch is diamond, a 10. Although the scale was created a long time ago, in 1812, it is still used today by field scientists who can use these hardness kits to identify unknown samples. Pause if you need to as we go through these, you guys. I will complete part 2 in just a second.